Okay, so 18.1, angles of rotation and radian measure. So we're going to talk about some vocabulary. This video is going to be a little bit long. These are some new words, new vocabulary. I want to make sure everybody understands. So an angle of rotation is an angle formed by starting and ending positions of a ray that rotates its end about a point. So we have this example here. The initial side is always in the positive x, and it rotates over to the terminal side where it ends somewhere in the other quadrant. This angle will be called theta, and this is kind of what it looks like. This is called part of a unit circle. We're going to be talking a lot about the unit circle. Okay, so this is what we're talking about. It's starting and ending. It's one ray that kind of rotates out, and the angle is formed in here. That's called an angle of rotation. So moving on, if the rotation for an angle theta is less than one revolution, which means it only goes around less than one time, in a counterclockwise position. So if I may, looking at this, we always go counterclockwise, and if it's going less than one rotation, that means that the angle of theta, the measure of it, is going to be between 0 and 360 degrees. Okay? A full circle is 360 degrees. An angle of rotation measured clockwise, so going from the clock's way, from standard position, so it starts always here, and it moves this way. So the one that starts here and goes this direction has a negative angle measure. Okay? So when we go counterclockwise from the terminal or from the initial side, the positive x-axis, then it's going to be a positive measurement. And when it starts on the positive x-axis and it goes clockwise, it's going to be a negative angle measure. So coterminal angles are angles that share the same terminal side. So if you notice here in this picture, the red angle is starting on the positive x and it's going this way to 257 degrees, which puts us in the third quadrant. That's a positive measure. Now, the purple angle goes the other way. So it's starting at the initial side going this way. But if I take the absolute value of them, they share. One, they have to add to 360. That's kind of the catch if you use the absolute values of them. But they share this terminal side. So 103 gets the same point that the 257 gets to, going the opposite direction. So the 257 angle is positive because it's going counterclockwise. And the 103 is negative because it's going counterclockwise. But because they end at the same ray here, and they have that same terminal side where the angle terminates, they're called coterminal angles. All right, so we're going to look at drawing an angle of rotation to 310 degrees. We're going to answer some questions about it. So we're going to first draw our quadrants. So we're drawing an angle of rotation 310 degrees. So first of all, we're going to get this x and y axis up, and we're going to draw an angle. Remember, we always start on the positive x. Here is our ray, and we're going to rotate it around so it's 310 degrees. So I want you to think about this. A full circle is 360. Up to here is 90 degrees. And over here is 180 if I'm starting here and going this way. And then down here would be 270. And this would be either 0 or full 360 if I went all the way around the circle. So 310 degrees is going to be somewhere in here. So I have to travel along this direction, because remember, we go counterclockwise, to get to where there would be 310 degrees. And usually we write it here in that quadrant. The question is, what quadrant is the terminal side? This is Q1, this is Q2, this is Q3, and this is quadrant 4. So to answer that, that would be quadrant 4. The terminal side is in quadrant 4 because 310 degrees is between 270 and 360. Then it says, on the same graph, draw a positive coterminal angle. What is the measure of the angle? So if we want another angle that's still positive, which means we have to go counterclockwise, but we want it to end at this same spot. And it's going to have a different measure because it has to be a different angle. So I've got to go this way, but this is what's going to happen is I'm going to go past it, come all the way back around to this. So I actually went 360 degrees, plus I went an additional 310. So that angle measure is 670 degrees. So I could actually do it again and have twice around. That would be 720 plus the 310. So I can keep doing that and make more circles going around. Have the same terminal side. Then it says, on the same graph, draw a negative coterminal angle. So the key here is the word coterminal. What is the measure of the angle? So let's see if I can find a marker real quick that'll work. Let's try the orange, see if you guys can see it. So that means I'm going to start here, and I'm going to go to this red line. And hopefully you guys can see that orange. So I'm going backwards. So from 360 to 310, that's a negative 50 degrees. So I'm going from 360 to 310, means I'm going back negative 50 degrees. Okay? So that is the coterminal angle. It ends in the same spot, but it's a negative 50 degrees. We'll practice more of these tomorrow. We have one last little thing that we're going to talk about. It's converting radian measures. I'm going to slide this over. Looking at radian measures. Radian measures is an angle of rotation has 225 degrees. And this is kind of a verbal explanation here. Let's see, what if I slide this desk over? I think that might help get a little bit more focus. An angle of rotation is 225 degrees counterclockwise. There are 360 degrees in a circle. Okay, 225 represents 5/8 of the total degrees in circle. If we take the 225 and divide it by 360, we get a fraction, 5/8. So we're using up, in 225 degrees, we're using up 5/8 of the 360. That means that we're using up 5/8 of the circle's arc length. Remember, arc length is just part of the circumference. On a unit circle, the radius is 1 inch. It's always 1, or 1 centimeter, or 1 meter, 1 yard. It's just radius is 1. To find circumference, that's 2 pi times the radius. So the arc length would be 2 pi times 5/8 of an angle of 225 degrees. That is equal to 5 pi over 4. So if we simplify this, and we put a 1 underneath the 2 pi, and we multiply across, that gives me 10 pi over 8. And then you reduce that down, you get the 5 pi over 4. That's the ratio of the arc length to the radius, which is what radians represent. Radians are a ratio of the arc length to the radius. This is the idea we use to convert between radian and degree measures. This is really super simple, guys. We're going to take our degrees and convert them to arc length, or to radians, and radians to degrees. We're going to multiply our degree value always by the same ratio. So we're going to take our 20 and we're going to multiply it times pi over 180. So we're going to put a 1 under the 20. This gives me 20 pi over 180. If I reduce that down, that's pi over 9. And that's the radian measure. That is the ratio between the arc length and the radius. Now, 600, same thing. We're still doing pi over 180. So 600 degrees times pi over 180 gives me 600 pi over 180. And when I reduce that down, you can use your calculators if you need to. Those cancel out, and we get, what is that, 10 pi over 3? And then the negative 60, same idea. Multiply it by pi over 180, put a 1 under this, and simplify, except our value in this case, when we change it to radians, is going to be a negative 60 pi over 180, which gives me negative pi over 3. That negative can stay up at the pi, or it can be written right there in the middle. Now, we're going to practice converting some radians to degrees. To convert radians to degrees, we want the pi to cancel out, so we're left with only degrees. So all we do is take the same ratio that we've been using, and we're going to multiply it, but we're going to flip it over. So we're going to multiply these by 180 over pi. Now, I know that we talked about a full circle being 360 and 2 pi, but you do realize that 360 divided by 2 is 180, and 2 pi divided by 2 is pi. We just kind of simplified our ratio here. So on this one, I get 180 pi over 8 pi, and I go about simplifying. Notice the pi's cancel. So I have 180 divided by 8. I'm going to get my little cheat sheet here. That's 22.5 degrees. For example, here, I'm going to take 180 and I'm going to divide it by pi, or multiply it. So when I multiply across, I have 9 times 180 divided by pi divided by 2 pi. Well, that ends up giving me 810 degrees. Because the pi's cancel out, we can cross cancel this. 9 times 90 is going to be 810. And likewise, the negative radians, we still multiply it by 180 times pi. So when I get this, I get negative 13 times 180 over 6 pi. Well, the pi's cancel. This goes into the 80 30 times. So we end up with a negative 390 degrees. We're going to practice this and practice some things on the unit circle. And we'll be using that unit circle for the next few days. Make sure you have all of this written in your notes.